Hello, everyone, and welcome to tonight's Psychology Presents on Artificial Intelligence and the Future of Human Learning. I'm Annette Stanton, and I have the honor of chairing the Department of Psychology here at UCLA. What is artificial intelligence, and how does it compare to human intelligence? What new possibilities are created by recent advances in AI for the future of human learning? These are the exciting questions we'll be asking of our two esteemed psychology professors tonight. Following their presentations, we look forward to taking questions from you, which you can submit through the Q&A feature at the bottom of your screen. Please feel free to submit your questions anytime and note that the chat function is turned off. I'd first like to share a little bit about our department. UCLA Psychology is a leading department in the nation and the world. We have foremost experts in psychology and neuroscience who conduct innovative and impactful research and education in behavioral neuroscience, cognitive, clinical, developmental, health, quantitative, and social psychology. We have more than 4,600 undergraduates enrolled in our 3 psychology majors, and we have more than 200 doctoral students who will be tomorrow's leaders in research, teaching, and public service. One of my favorite activities as chair is highlighting the exciting research and education conducted by psychology faculty members, along with their undergraduate and graduate students and postdoctoral scholars. Tonight's event is the 9th in our Psychology Presents series, and I hope you enjoy it. Now, it's my great pleasure to introduce the 2 superb faculty members who will be speaking with us this evening. First, I'm pleased to introduce Dr. Hongjing Lu. Dr. Lu is professor in the Department of Psychology with a primary focus on cognitive psychology. Her lab investigates how humans learn and reason and how intelligence machines may emulate them. Dr. Lu's lab approaches these questions by intertwining perception and higher cognition. The work in her lab, the Computational Vision and Learning Lab at UCLA, is highly interdisciplinary, integrating theories and methods from psychology, statistics, computer vision, machine learning, and computational neuroscience. Please join me in welcoming Dr. Lu. Take it away.
Okay, hello everyone. I'm Hongjing Lu, and a faculty member and from cognitive area and in the Department of Psychology. It's my great pleasure today and then to share some of our research projects with you on the similarity and the differences between human and intelligence and machine and intelligence. So in the past few years, and then you have heard the terms of the great leap of AI. And then I will start from and then back to 2016. And this is a featured article at the New York Times and magazine, and with the title of The Great AI Awakening. So, and in this article, it's mainly talking about how Google and use advanced AI algorithms to improve and Google Translate. At the same time, and then not only in the language front, and also in the perception and image processing front, and then we noticed that and all these types of the models and in computer vision, they started also to make a breakthrough. They're able to recognize the objects and in the images, and then to perform object recognition at the human level performance. And so this is a quite a remarkable achievement. So 1 year later, and then this is a cover page and from the Journal of Science, and they're talking about AI is not just transforming science, and it's also going to impact the daily life and the speaking to your phone, to you and in your cell phone, and then taking the road and in self-driving cars. And 6 years later, and then this is the last Christmas, and then we all had the experience and then to play with ChatGPT. And so within these short 6 years, the AI system have been making a remarkable progress and in a broad range of tasks. And for many tasks, they get close or even surpass human performance. So for example, under the images, and then for perception, and then in 2016, they can recognize objects. But now in today, and 7 years later, they can generate and then realistic and photograph they can generate and all this kind of artistic work, and just from one prompt of generating an astronaut and writing a horse. They also can generate and these types of artistic work like the Starry Night and mimic and Van Gogh style. And the language, and then 16 years ago, and the focus and has 6 years ago, sorry, and the focus has been on translation from one language and to another language. And in today, and then this is the ChatGPT's performance. And then I actually just simply asked it and then to write introductions remark and to introduce the next speaker and my colleague and James Stigler. I love to read on one sentence, and then the ChatGPT wrote, and the Jim as a master of his craft, a titan of the world of in education and a true expert and in unraveling under the mystery of learning. And then they also just know and what James research about. And then there is like Mark's like and James, and then possesses a superpower, and that many of us can only dream of the ability, and then to make and the statistics as the latest blockbuster movie. And trust me, and when I say that, this man can turn a graph into a grieving tale. So this is a very impressive performance because and the system and show these very flexible ways. And in presenting information, you can ask it and to write, and then this introductory remark, and for the different contexts and the research seminar, and then the output is very different. So all this recent progress and in artificial intelligence, and really, and then provides opportunity for us to ask the old question, and what is unique about human intelligence? If we think about this question, and then we can first think about it, and the brains and the cause minds, and then our like thinking and our perception, and is supported by this biological system, and with 100 billion neurons and about 100 trillion connections. And then within this system, we have neurons, and then they have fire rate, and when they get the stimulation, and then they will fire, and within about like 1 to 200 times per second. And then, so besides, and then we have this biological system and to support the human intelligence, there are also other types of limitations we need to consider, and they are applying to human beings. So for example, and then we have a limited time and to learn, and the maximum time for individuals of learning is our lifespan. And we also have a limited computation. So, and then for the brain, and then we have these kind of biological constraints and lead to, we have limited working memory. We also have limited attention span. And then I'll give you a very simple example. Back to the start point of artificial intelligence back to 1997. And then there was a big news that Deep Blue and developed at CMU, and then they won the chess, and then they beat down the human champions. But for that very old AI system, this system can search positions, and in the order of 100 million to 200 million positions per second. But for human chess master, we can only search 6 steps per second. There's a huge difference about the computation resources. So last one, we also have the limited communication. We cannot copy all the information stored from one brain to another brain. And then just as a copying and then the data, the files from one computer to another computer. Despite the giving and all these limitations, and then the question for us is that these limitations actually could shape up the unique aspect of human intelligence. So as a psychologist, can we identify the differences between humans and AIs? The answer is actually yes. I want to showcase and then 2 projects from my lab and then led by our graduate students and postdocs. So for the first project, and then we focus on shape perception. So we're very good at recognize shapes, and then from the images, from the line drawings, and from the cartoons, and then we even can recognize the Winnie the Pooh and from the cloud. And then this is also the beautiful architecture and the fragmented travelers, and from Bruno and Catalano, and then just to show we can recognize the shapes and in a very flexible way. And there are developmental studies to show that the shapes turned out to be the first primary cues and for young children and to develop the perception, and also there are the words related shapes, and then they have been acquired much earlier than the other types of words and related texture and so on. So Nick asked a very good question, is that back to 2016, and all these models, and which called the deep convolutional neural network model, and they can achieve and the human level performance in recognize objects in images. So can they recognize or see shapes as what we would see as humans? So what Nick did is to apply some common experimental manipulations that we used to study human visual perception in psychology. So what he created and this kind of new object from the shape, and it's a teapot, but he imposed the texture and from the different object. So the texture for this teapot and it come from the golf ball. And then, for example, this is the shape of the camel, but the texture and come from the zebra. And then this is like a special object and with unusual and the materials like the figurine and so on. So when he tested this, and then humans, and then the responses primarily go for the shapes. But if you test and with the deep convolutional neural network model, these AI models, and then their conclusions, and with very high confidence, will go to the texture. So this is number one, and what we showed, and this system judgment, and strongly biased to texture, not the shape of the object, very different from humans. So another very clever and manipulation, and Nick did, is that to scramble the different parts of the object. If we see this object, you probably will frown and to think, what's this object? But with the AI systems, and they are very confident to tell you, this is a camel, this is a hammer, and this is a microphone, this is the war plane. Why? It's because and then what Nick and generated these images just by skip the local and the information and for parts, but to scramble it. Somehow, and then these types of a system will take advantage of this local information, and so that and to recognize the objects. So the take-home message and from Nick's study is that these types of the models and trained with the classification task and they really fail and to see object shapes. So the second quick project, I will quickly go through a project, is that we can test and then this system, not only using images, and we also can look at the verbal stimulus. And then this is the work and led by our postdoc and Taylor Webb. So what Taylor has been doing has been tracking under this large language model, and then within 7 years, under this large language model, and make a remarkable advancement. So for all kinds of like verbal tasks, and they can do as well as humans. And so he's asking the question, how about analogy? So this is the types of a task is that you can create these novel situations and to ask people and then to make the judgment. So he created and then these types of analogy problems, and then you can give and then just based upon the alphabetical of the letters, and then you can apply some rules and can ask the system to complete the pattern. So lo and behold, and then what he used, and then you can manipulate the different types of the rules and to create many different problems here. So this just show and the different types of transformation types. So it actually turns out, and then these models are doing very well. And so the idea here, and in this case, and then the blue, and then indicates it's the GTP3, basically the similar system for ChatGTP, and the humans are the UCLA students. So this system are doing almost as well as human participants, and for most, and then these rules, and then without giving this is the first time they see this problem. And then Taylor basically asked another question: can we make it harder? So now we also can create the situation. You have to transfer and these types of reasoning and from alphabet and letters and to these types of real life and the situations from them to, for example, the magnitude of the temperature. Then it turns out and these types of system also is doing on average and as good as a human participant. That's very impressive and to us, because that just showed that this type of system started to show some emergent ability and in solving the problem and through reasoning. But the last hint, and then what they're not good at it, is that we look into some real problem solving. So this is actually from the developmental study, and then showing and the young children and 4 to 6 years old, and they're asking them to try to find a way to transport these gumballs and from one container to another container. And then the kids were offering the different tools and to solve this problem. And then if you only give the problem, the young kids cannot do it. But if you give them a story, it's related. It's called the magic staff story. The story and involves a magic genie and will move and from old place and to a new home and want to transport the collection of joy. And what the genie is going to do is use the magic staff and to pull and then this new home over the next and then transform the joy and by hand. After listening and these fictitious stories, and then the young children actually can solve this problem. They will select the tools as the working king and to solve the problem. And similarly, in the ways as this genie and in this magic story. But if you give the same material, including the source stories, and then to GTP3, and then AI system cannot discover the solution. And this system tend to propose a very elaborated but mechanically nonsensical solutions for this case. So the take-home message is that even though it starts to show this emergent ability and to find the solutions, but its reasoning ability still is limited by the lack of physical understanding of the world. So at the beginning, I mentioned about all these limitations. Whenever we talk about the limitations, that seems it's a bad thing. But actually, we believe in all these limitations, they shape up the human intelligence. Because we have the limited time to learn, we have the limited amount of the data to learn, and so that leads to the efficient and rapid learning. Because we have the limited computational resources, and then that leads to we naturally develop ability to break down problems into parts. We go for more relational thinking, and then we're trying to re-represent the entities and the relations in the world, and then to form a better schema and for decision making. So limited communications, that also leads to the teaching system and for human beings, so we can get this cumulative cultural evolution. So these days, and then we're all talking about how great and the AI system is, but I also want to remind us, and then we do have this all unique aspect of human intelligence. So at the end, and I want to share, and then the one quote from our colleagues from the Alison Gopnik and from UC Berkeley, and then the idea here is that human intelligence is still unique in its own way. And the core is that we can develop the ability of learning to learn and being creative and being collaborative. As Alison said, and we humans and will need to be much smarter than we have been in the past to properly regulate the new technologies. Thanks.
Thank you, Dr. Lu. That's fascinating, and I'm glad, although we have many limitations as humans, we still have some unique qualities. So now I would like to introduce Dr. James Stigler. Dr. Stigler is a distinguished professor in the Department of Psychology with a primary focus on developmental psychology and a secondary focus on cognitive psychology. Dr. Stigler's research focuses on understanding the processes of teaching and learning in complex domains, such as mathematics, science, and statistics. His lab, the Teaching and Learning Lab at UCLA, also looks at the impact of culture and technology on learning and applications of improvement science to education. He is co-author of 2 popular books, The Teaching Gap with James Hebert and The Learning Gap with Harold Stevenson. He's co-founder of 2 educational technology startups, Lesson Lab and Zaption, and the nonprofit Coursecada, which we'll hear something about. Welcome, Jim, and take it away.
Hello, everybody. It's an honor to be here. What I'd like to do is just tell you a little bit about the Teaching and Learning Lab and what we're doing currently in our work here, and then talk a little bit about how, why we're excited about some of the new large language models and how we might apply them in our work. Although I do want to say from the very beginning, unlike my colleague Hongjing, I am not an expert on AI, not really even a novice. but more of a consumer of artificial intelligence and trying to figure out how it can be used to support human learning. The focus of my lab, or the theme of the work that we're doing, is researching how students learn things that are hard to learn, like math and science. And one of the things I want to point out is that a lot of research on learning in psychology has focused not on things that are hard to learn, but on things that are relatively easy to learn. And the main reason I think for that is that a lot of our research subjects end up being introductory psychology students, and we usually get them for about 1 hour. So if we're studying learning, most studies are going to say, what can you learn in an hour? But the things we really care about students learning, you can't learn in an hour. It takes weeks, months, sometimes even years in order to learn things. And that's what we're trying to figure out how to study in our lab. Now, it's really hard to study things that you might learn over weeks and months. And how do we do that? The first thing we did about 5 years ago is we started thinking about, hey, if we're going to study how we learn things that are hard to learn, let's develop a setting in which we can do this research. And so what we did is we decided to develop a highly interactive online textbook that could be used for teaching introductory students. So here's just a little bit of an image to convey what this book looks like. My collaborator and I work very closely with Professor Ji Sun at Cal State LA. We decided to write version 1.0 of an introductory statistics and data science textbook, which has now been used by more than 20,000 students. We started out in college. It's also being used in high schools now, or some versions of it are. The book is highly interactive. On each page, there's text and graphics, but there's also, throughout this textbook, more than 1,500 formative assessment questions. So as students are going through this book, they'll answer a multiple choice question, they'll answer an open response question, and then they might write some R code and run a coding exercise right in the page in the book. So we develop a huge amount of data from students as they're going through this book. So I call this, what we had originally wrote, version 1.0, because our focus now is on how do we develop an R&D process for actually continuously improving this book. So one of the things we did is we developed a platform for delivering this online to students through standard learning management platforms. And we figured out a way to take all the data that's being generated and de-identify it as it's being collected. So we don't have to worry about privacy and confidentiality concerns. And then we've developed a network of researchers actually all over the country who are doing, also people who are interested in doing research on learning hard things in authentic settings. And they're able to actually immediately access the data generated by our students and begin trying to understand how it is students are developing knowledge of statistics over the course of a whole course. The platform we developed also makes it possible to do random assignment experiments. So we actually have experiments going on where random subsets of students within a class might be getting one version of a page or another version of a page. What's really nice about this as a research project is it's the first time in my career I've ever experienced the research that I do. Actually, if I discover something that makes the book a little better in terms of student learning, I can immediately apply that back to an improvement in the instructional materials. And I think that interests a lot of the researchers who are getting involved. So let's talk about the design of the book. The design of the book actually is based on a particular hypothesis we have about how people learn things that are hard to learn. We call it the practicing connections hypothesis. And I want to just tell you a little bit about that. It starts with an observation that we have. If you look at all these things, statistic, parameter, sum of squares, if you ever took an introductory stats course, you learned a lot of these things. And we call these the bits. These are the things that you always get taught in an introductory statistics class. And the traditional view of how people learn, we take how they learn small things and we've applied it to how they learn big things. So for example, the whole mastery learning approach assumes, well, if you just study all these different bits and you learn them all to mastery, then you know statistics. Well, it turns out, based on our experience, the students can learn all these bits, but not see the connections among them. And if they don't understand the connections among these ideas, they're not going to be able to transfer their knowledge to new situations. So our hypothesis is that if knowledge is not coherent or connected, it's going to be difficult for it to transfer. So I brought an image from the most recent fMRI equipment of two guys' brains. That's a joke, by the way. I wouldn't know how to use an fMRI myself. But it's interesting, this is just a schematic to show basically what our theory is here. Our thoughts are, if you're the guy on the left, you know all the same things as the guy on the right. You know A, B, C, D, E, F, G, H, etc. And if you get into a situation like you're studying a problem and the answer is to apply concept B to the situation, the guy on the left has no way to get to concept B. He's got a connection to concept E, and he's got a connection to concept D, but the rest of the stuff is sort of just all left isolated bits of inert knowledge. The guy on the right, all his knowledge is interconnected. So yes, he first goes to E, which may not be the solution he's looking for, but from E, he can go to D, and from D, he can go to C, and that gets him to B, or he can go to F, and that gets him to B, etc. So the idea here is that if your goal is transfer, what we need is to figure out how to build connections and coherence in people's knowledge. And this is the idea that we're really focused on. So basically, to put it in a nutshell, if your goal is learning that's transferable, then maybe what we should practice is not the bits, but the connections that make the knowledge transferable. And these connections would be connections between different concepts, between different representations, and also between situations in the world. So now, how does AI fit into all that? Well, frankly, up until the advent of these large language models, and it's really interesting to listen to Hongjing's description of the history, because it's really true. These changes in the capabilities of AI have been very sudden. But in educational technology, where I've had a lot of experience, most uses of machine learning, which is sort of an earlier form of artificial intelligence, have been based on sort of a bits model of teaching and learning. So the focus, first of all, has been on assessment. And so, for example, this is actually the first part of a conversation from ChatGPT, where it's asking me, could I tell you what does the term statistical model mean to you? And using the sort of previous artificial intelligence techniques that we were able to use, we could actually auto score it. If somebody answered, it means some Greek letters, that was my answer to ChatGPT, it says wrong. That's not it. And then what it does is there might be also other machine learning algorithms that can match me up, kind of like Netflix recommends a movie. It might recommend I watch a couple of YouTube videos on what is a statistical model, et cetera. Never got excited about this because it doesn't really engage students in building the connections that we want them to build amongst the core concepts. So generative AI is actually potentially a game changer for it. Here is just an example from a project I've been working on with one of my graduate students, Alice Xu. We're looking at how can we build conversational models for assessing what students understand. So assessment of being able to do things is something that's pretty straightforward, but to understand whether a student understands a concept, especially a really complex concept like statistical model, is not easy. And what we can see here is the follow-on to this conversation. So I said, statistical model means some Greek letters, and it said, thank you for sharing your thoughts. Of course, the key behind all this is how do you design the prompts to get the AI to engage the students in the kind of learning process you want to engage them in. So it says it's true that Greek letters often come up in statistical models. However, let's dig a little deeper. Can you tell me more about what you think these Greek letters or parameters might represent in the context of a statistical model and how they might be used to make predictions? After that, I make a fairly smarter answer. I say, well, a model could be like a math sentence that tells you how to make a prediction based on a variable. And then it tells me that's a good start. Yes, a statistical model can do that, but to take your understanding a bit farther, what does it mean to fit a model in statistics, and so on. And so we were able to put in to the prompt all the different connections we wanted students to make, but then rather than just telling the students what the connections are, the students were engaged in a process, starting with what they knew and being able to apply it to connect one concept to another, to a situation, and let this produce learning. So we have an official partnership with OpenAI right now, where they give us free access to their API, and we're using ChatGPT-4 for a number of interesting projects that literally were not possible before, but yet we believe help change the nature of what it means to learn in complex domains. So like I just showed you, we're doing conversational assessment of understanding. We also, in our 1,500 questions in our book, we have hundreds and hundreds of open response questions, because we believe getting students to try to write down their thinking is very important. But now we can give a very different kind of feedback to students that helps connect one concept or one misconception to a concept that would help clarify it. We can take authentic data analysis assignments and have machines score those. We can answer students' questions that they have in reference to core ideas. But also, and this last one I think is the most interesting to me right now, is we can foster curiosity and agency, because it's very clear as we move on, just getting the coherent answer from ChatGPT, anybody can type in a question and get a good answer, but how do students actually learn to be curious enough to keep asking questions and so on? So, this is a video that you may have seen. It's a meme that's been floating around the internet, but I think it's very relevant to this different kind of learning that we're trying to figure out how to produce. This is a baby bird who up until very recently was being fed by its mother. And it knows somehow it's supposed to open its mouth and that worm is going to jump in. But guess what? The worm doesn't jump in its mouth. The bird has to go out and grab the worm and eat the worm. And we worry that in our lab that some of the things we do with students might be socializing them to have a particular view of learning, which is to be prepared to have the teacher drop something right into their brain and therefore they're going to learn it. What we're trying to do is figure out how we can use new AI tools to socialize them to have a different view of what it means for themselves to learn and to give them the kinds of qualities like curiosity and the ability to ask good questions that might lead them further along that path. And that's it. I want to just acknowledge our course kata team, and I'll turn it back to Annette.
Thank you, Jim. That's really fascinating, and it's great to see AI being used to facilitate learning. So now it's the audience's turn. So your turn to ask questions, and I'm going to moderate that and read some of your questions. And Hongjing, would you join us too, please? Okay, so Drs. Lu and Stigler are here to answer your questions. So here's a first question from an audience member. I find that even college students have difficulty with computational problems presented as word problems. Does AI have a similar challenge, or in terms of understanding word problems, or is the way information presented not a problem when AI is involved? Hongjing, maybe you could start that.
Yeah, I can start with this. I think if the problem presented and in this word and a text form, and then it's a good input and for a large language model. However, and then when you twist and then the problems, for example, by deleting a sentence, sometimes this system will suddenly change and then the solution here. And sometimes it will make the mistakes and then similar as what my students will make. But in some cases, will make the mistakes. It's very, very unusual. You don't know what's going on there. So I think it's like we're just in a very gray area. Part of the reason for me as a kind of a researcher who are trying to understand this system is that we don't know what it's doing. All we can observe and it's the behavior. But the behavior of this system actually can change very quickly. And sometimes the context and sometimes like one sentence and really can change the solutions here. And then, so that's kind of like, it's more like I have more questions than providing the answers here. So in some situations, they do mimic and then some of the issues and our students and the experience, but sometimes and they will show the problems. It's very different and from the learning situations.
Thank you. Let me move to a different question from the audience. It seems that AI could be used by students in a way similar to the Socratic method, that is, learning by being asked questions. Will this change professors' teaching through use of AI? Jim, do you have thought about that?
I think it'll definitely change professors' teaching. I just think we're at the very earliest stages of knowing what that's going to look like. I mean, for one thing, we used to think we needed detailed information about the students in order to personalize the learning and reach them individually. What's interesting about these large language models is they don't know, well, currently they don't know anything about the students. Now we could have them learn a history. For example, one of the things we're exploring in our textbook is we can actually save, if we have an AI tutor present during the course, we can save all the interactions it has with a particular student, and it can actually remind the student, oh, 2 weeks ago you asked this question, what you're asking now is kind of related to that. And those kind of things are very exciting. Those are very hard to do as a teacher, but what's amazing to me is what it can do without any knowledge of the students at all. So it's really quite striking that way.
Right.
So, go ahead, Hongjing, because I'm interested in how AI can be personalized. Go ahead.
Oh, I want to just add on like what James talking about is like the AI could become very useful tools and for teaching. And then in one of our studies, and then we actually just we can make the AI system, basically ChatGPT, as a human subject. We can present the different materials in different orders. And then we can see how that could change and the behaviors and then the decisions and so on. So that's for the teaching's perspective, that will be very helpful for us, how we present the information. And so that can maximize and then the students learning to see the connections between the different concepts and rather than just simply memorizing. So I think it's a very useful tool and for future teaching.
And I'm a student and I'm using an AI tutor, can that AI tutor learn, can it learn my particular way of solving problems and help me get out of a particular way if it's not working well?
Yeah, that's like a specialty for ChatGPT. So kind of like the other model, I was talking about GPT-3, and the difference between the GPT-3 and the ChatGPT, the ChatGPT really more go for the like an individual and then personalize it. They're trying to infer and what this person wants and what's the style and this person is doing. And the GPT-3 is more like a rational model. I want to make the best decisions based on all the statistics. So they have slightly different cost function involved, but I think that individualized tutoring, it will be one of the very good use and for these types of systems.
I mean, it's a great research question. Just in terms of tutoring, the tutoring literature is really not very deep, but something like ChatGPT, we can actually experiment with different kinds of prompts. So for example, is it better to have a teacher that keeps probing and asking questions, or is it better that the tutor follows a question with a little mini explanation, for example? And we can literally test those two in a random assignment experiment and see which ones produce more learning. And it's possible that some would be better for certain types of students, which we could learn something about than others. But I think it's just as a research tool, it gives us the ability to study things like tutoring in a way that's been very hard in the past.
Thank you. Here's another question. ChatGPT can be told incorrect information and it accepts it, like 2 + 2 = 5. Humans wouldn't do this. This seems like a fundamental difference between AI and human reasoning, at least in ChatGPT. Can you comment on this difference?
Okay, I can start with this. Yes, and then sometimes we do find under this system and make very odd mistakes. So that's part of the reason we emphasize it's a tool and to facilitate learning, but it should not be a replacement of learning. And then one of the issues, for example, I was talking with one of the friends in the industry, they have been using this system for writing code and then the program code and then for the company. At the beginning, everyone is very excited. But then when they really get into the application, they notice that this system started to make mistakes, very odd mistakes. It will take the human and then programmer longer time to debug it because we never make any mistakes like that. And then so when we use and then these types of the AI system, and then we have to keep reminding ourselves, and then this is a tool and to use. For example, I always tell my students, if you have a paper assignment, read the paper. It's just not let ChatGPT give you a summary because they do make up information. So this is like the risk or dark side of the generative AI. You do need to be aware of that.
I think Hongjing gave a very good example of it making up all kinds of false information in her introduction of me that she presented. I think it's interesting because ChatGPT is really good at writing a coherent paragraph, even though it may be an incorrect paragraph. And so I think it's possible that one of the things that people will become more interested in is how do we develop some of the qualities that we don't really do research on much anymore, like wisdom and judgment. I think those kind of things may be much more important in the future, not just can you write a paragraph, but can you have sort of the depth and the perspective and the conceptual understanding to figure out whether it makes sense or not, and whether it will advance whatever it is you're trying to work on.
Thank you. This is another question that points out a potential problem. Somebody's worries that large language models, or AI, may pose a problem because students and professionals, all of us, may delegate writing and complicated thinking involved in writing to AI. Plagiarism and essay assignments also would be another issue. Are there ways to deal with these kinds of potential problems?
I think this is a very good question. I do think that we have the researchers and working on these types of the problems. And then the idea is that you are trying to figure out and what are generated by these AI systems and what are the genuine work and then from the students. So one of the things I think if you are the computer scientist, you know that there's a Turing test, and then you gave like one of like the piece of the information, you see whether you can fool and then human eyes. Right now, and this system really can pass the Turing test, and then they provide us this essay. We cannot tell it's written by the generative AI or it's written by a researcher. And there are several studies already show that. And so I do think there's a need to have some kind of like regulation. So what I was heard, and then I think the government and the big companies like OpenAI and then Google, they're starting to talk about it. The simple thing, and you should have the digital and the watermark, and on any of the things, the text, the image, and generated and by these AI systems. And then I do think that these types of the regulation will be needed, and then for the application, also for education.
Yeah, all that's true, and it'll be interesting to see what happens. But it's also a good question do we really want to say if something was assisted by an AI, that shouldn't count as your work? I mean, we all use computers and word processors, which has made our writing a lot faster and a lot better. Should that be considered cheating because we used to write in handwriting, or it should just be a tool that makes our work better? It's interesting. I had a conversation with an undergraduate student recently who a colleague introduced me to, And he was telling me that he had used ChatGPT to help him write his term paper for a course. And I was horrified at first. I said, really? Why are you telling me this? You know, and he said, well, it was really helpful because he said it helped me really find places where I had left out some important connections and places where an idea that I should have put in might have been there. And he was talking about it, and I thought it was very interesting. And then at the end, he said, I feel like I'm not a very good writer, but it helped me be more the person who I think I really am. I expressed myself better. And I thought, I don't think it's so black and white. I think as time goes on, it's not necessarily cheating to use AI as an assistant, but it's going to be very fast changing, and how we adopt norms for this new world is going to be pretty interesting to see happen.
Thank you. Well, let's continue talking about the, some of the risks of AI. There's a question, of course, about what AI is based on. It's based on data that's fed in, and talk a little bit about the representation of marginalized groups. Can we avoid bias in AI information? Hongjing, do you want to start with that?
Right. I think that's a very good question. And then I think, first of all, and then all these AI systems, especially large language models, and then their training data is humongous, and no single individuals and can compete with that. And then give you the simple idea is that, and then 40% of their training data, and then for ChatGPT, and then they come from all the text on the web, all the digitalized book, and the Wikipedia. That's just 40% of their training data. The other 60% are computer program code. And then if you think about the text, and then this system read, and then it's almost, if you read all the text and then to a person, it will take like 5,000 years, and then to finish and reading under the text here. So, and their training data basically is really built on the entire and the human kind of knowledge. And then in this case, and the scope is much larger. But now, and then when we get into this bias issue, and then there's a lot of the bias and in the data itself. So I think it's hard to completely remove and the bias issue, but we need to work on it. And then we need to first be aware, and there are biases, and then in these AI systems. It's kind of like in psychology, we study human biases, and we know we have this implicit bias when we make decisions. And then we also have like the experimental method, and then to measure these biases. And then we have all the other types of work, and then to show and how humans and then we and then fight with these type of biases, and then try to make a good decisions. So I think there's a lot of like the research angles by combining and then human biases in psychology, and then will help us and to mitigate and these biases and in the AI systems. And also as a user, as a consumer, we need to be always aware and of these biases. And then, so if I think there are the multiple levels of the ways that we can help. So first, and then for this kind of the people and who work and then to develop this AI system, you need to have a team and with the diversity. And so all these types of biases and it should be considered and in the first place and when developing and these types of system. So all this data should be transparent. And then as a researcher, we study this system, and then especially the recent version, for us, it's such a black box, and the data is not transparent to us. We don't know what kind of biases and they're in this data. And then if you don't know that, it will be very hard and to mitigate that. And then the third, and then we do need this collaboration and between the cooperation and the governments, and then to regulate, and then these types of things. And I do think that we need this kind of collaborative work kind of from academic and from collaboration, the individuals and the government, and then to really work on this bias issue and then AIs, because and it is a very big risk and for using these systems.
If I weren't already a researcher, I think you both would be convincing me how important research is to everything we do in AI and in learning in general. And so will AI, here's another question, will AI actually change brain development in the future of students, of children?
James, do you want to start it?
was
I'm
gonna
the
let you-
developmental psychologist.
I'm going to say yes, because all input changes brain development. Brains are continually developing. And so the tasks that we're asked to perform are going to be different in a world where there's a lot of AI. Some of the older technologies came in and when we first got industrialization and the loom, we used technology to do things that a lot of people didn't want to do, and they were happy to see the machine. The real question is going to be, just because AI can do something, does that mean we're no longer allowed to do it? For example, if AI gets really good at thinking, does that mean I'm not supposed to think? I think that's one thing I think about, is that in a sense could take away our humanity. In other words, if AI could go on a hike, would I want to just let it go on a hike instead of me going on a hike? No, I want to go on the hike. So I think we have to really focus in on what we value doing. But I think that there's a lot of stuff that it's going to do that's going to change. It will change our brains, just like all our experiences change our brains. That's my prediction.
Yeah, I agree. I think it will impact the brain development and will impact the strategies and we're making, and then especially for decision making, and we have this kind of fast versus slow process, and then we have make a very quick decision just based on our heuristics. But in back of our brain, we will tell us, wait a minute, and think more. And now with the AI assistance, and then maybe we have to start to use more strategies to think more, and then to verify and then the truthness of this information, this system, and provide it to us. We need to be more kind of intelligent and using these counterfactual ways, and then to think about the problems and then to make plans and so on. So I think it will change and then the ways of the brain development and also the strategy or styles we would use.
And so we have a lot of teachers, I think, on the question and answers, and there are questions about what kinds of things can we do to ensure that we really are promoting making connections, like you talked about, Jim, in terms of your work. And will we need to use things like in-class essays and in-class thinking exercises that really promote thinking on one's own or thinking maybe in teams, so that we don't rely on only AI? Jim, do you want to start with that one?
Well, I would just say, at UCLA, I actually teach our statistics class, but I teach it to a lot of students, 250 to 300 students, which is not ideal. And over time, most people who teach very large lecture classes lecture, and lecturing just involves giving students the bits of information they're supposed to put in their head and then giving them a multiple choice test. I think using AI, it gives me a lot of freedom to do things I could never do before. So for example, I already use a lot of writing in class. I'll ask the students, I'll put a question and have them write an answer to that question. But the AI would allow me, for example, to categorize students' answers on the spot and be able to notice that there are three main types of ways students answered this question, and one of them is based on a misconception, and I could actually deal with that right there in the class. So I think it's going to enable us to develop new kinds of pedagogical techniques, and it's going to just take a while for those to get invented by creative teachers, and then also research to find out which ones actually are beneficial in the short term and which ones are really beneficial in the long term. One of the things we don't do enough of is measure the effects of our teaching, a year, 2 years, 3 years later, but we really should be doing that, because what we're trying to do is produce students who have this kind of perspective that Hongjing was talking about, and the ability to think more deeply and with more perspective and with better judgment. And I think that's what we need to focus on. I think the idea that ChatGPT has access to, you know, all human knowledge, I guess, as of 2021, it sometimes reminds me, that's amazing because I don't have access to all human knowledge. So the fact that it can find things that are relevant to something I'm thinking about that I never would have found on my own, that's really a fantastic thing. And so I think there are dangers, but there are also just fantastic affordances that we're going to be discovering, and it's going to be happening very fast.
Fantastic. Hongjing, do you want to add to that?
Right, and then the other things I also think, especially at this moment, and what we commonly use and everyone uses ChatGPT is a large language model. So they have some and the conceptual knowledge, but they are also missing a big part of the knowledge. And then this knowledge can come from the physical knowledge, how the world and works, and the causal knowledge and why the things is about this. And also moral foundations and the social interactions. All these things are missing, and then in these types of model. And they add this kind of like a core and the conceptual knowledge do need under this kind of teaching environment, and then to help students and to get these types of knowledge and the related ability. So I think that's also in the future, and then using and then this AI system as a system, but really can foster the learning of the other types of the core conceptual knowledge.
Thank you. This question builds on this, I think. And it says, sadly, the proliferation of data on the internet has not improved human critical thinking skills. I am skeptical that AI can help human brains develop. Data crunching, yes. Critical thinking, not so much. Your thoughts?
I think for the critical thinking, and then it's the importantly, and then you can foster it, and then in the kind of teaching environment or learning environment, and through a group project, and then people can work together, and then provide the critics, and then to what this AI generated and the results and so on. So in a lot of situations, we find as educator, we find it's hard to do it because. And then you either find the pieces, ask the students and to give a criticism. Maybe it's just too easy, too obvious, or too detail oriented. It's not really at the connection and then between the different concepts. And then when you generate this looks like coherent argument and from the AI system, that's actually a very good target and to show the student what's missing. And then one of like a major project in our labs is really to look at this relational thinking and how they connect the different concepts and so on. We can find a very weak spot and in these types of the models. If you look at and within 3 sentences, look very coherent. But if you look at what they're talking about across paragraphs, and then you see the inconsistency there. So this actually gave a very good example to show the students and that which directions you need to look into and then to evaluate and these types of information.
Well, I'm afraid that's our cue that that we are out of time. It feels like the 3 of us get to go and have some dinner together and keep talking about these concepts. And I actually wish we could bring all of you with us. This webinar has been recorded, and we'll send a post-event email with the link to the recording to everyone who's registered. And we hope you'll be able to join us for our next Psychology Presents, and I absolutely hope it's as fascinating as this one has been with Dr. Jim Stigler and Dr. Hongjing Lu. Thank you, everybody, and have a good evening.
Thank you.
Thank you.